A manufacturer knows that their items have a normally distributed lifespan with a mean of 14 years and a standard deviation of 0.5 years. If you randomly purchase one item, what is the probability it will last longer than 15 years? The first thing you should do is sketch out a bell curve because it says that these are normally distributed lifespans, which means bell-shaped. Then you mark where 15 years would be in relationship to the mean with a standard deviation of 0.5, and you sketch, or rather shade, the region to the right since it's asking for the probability that the lifespan will be longer or greater than 15 years. This gives us a visual of the area we're trying to find. We can see that it's less than half of the bell curve, so we expect an answer that is less than 0.5, and it looks very small. Now the actual calculation is easy if you have a spreadsheet already set up, like I do. But I'll show you both how to do it with the spreadsheet and just from scratch if you don't have this already set up. So entering my mean of 14 years, my standard deviation of 0.5, and my x value of 15, I see that I get a z-score of 2. Now that z-score is calculated by using the z-score formula on the x value of 15 minus the mean of 14 and divided by the standard deviation of 0.5. Or if you have it set up to calculate using the references here to the different cells containing these values, my x value is in cell A8 minus the mean here in A5 divided by the standard deviation in B5. Now with a z-score of 2, I can look that up on the z-table. For positive z-score of 2, we have an area of 0.9772. Now, from the picture I have, 0.9772 in my sketch here should be the area to the left. So I want this area. So I can take the 0.9772, subtract it from 1, and get my answer. That rounds to 3 decimal places, 0.023. Now, you can also get it using norm.distribution or norm.dist. So the left area you can see is calculated as 0.9772 using norm.dist, and then the right area is calculated with 1 minus the left area. So let's see how to get that left area again. We would do equals norm.dist, put in your x value of 15, your mean of 14, standard deviation 0.5, and always true for cumulative, or you can type in a 1, which means yes to the computer. If I press enter, you can see I get my left area, and then the right area is 1 minus the left area. If you want to set this up so that it will refer to the cells containing these values, you can click on the X value cell, then the mean, comma, standard deviation, comma, 1 for cumulative. This way, anytime you change these cells, the answer will recalculate. So you can see we got that one right. Let's try it one more time. So you can see it's the same setup, a normally distributed lifespan with a mean of 10.1 years, a standard deviation of 2.7 years, and my answer then is going to be the probability that it will last longer than 3 years, so I need to change this to 3. And since I do want the probability of it lasting longer, I want the right area. So to 3 decimal places, That would be 0.996. Notice I could have gotten this by taking that z-score, negative 2.63. Look it up in the z-table for negative z-scores. Negative 2.63 would give me this area. That area is to the left. The area I want is to the right. That looks different than what I just found. No, it's about the same. It's just rounded differently. So then taking that and subtracting it from 1, I would end up with the same final answer.